Hello everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research. If you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So in previous lecture, we have seen a typical maximization problem, and in this problem we have two parts. So the first part we have already covered in the previous lecture, and now we will focus on solving the second part. So the question says that there are 5 batsmen P, Q, R, S, T and 5 batting positions, and the average runs scored by each batsman on each batting positions is given in this matrix, and we need to maximize the total runs scored. And now in the second part it says that if another batsman U within the following average runs in batting positions as given below. So another batsman U has been considered for batting position 1, 2, 3, 4, 5. He has certain averages, and if this U is added to the team, should he be included to play in the team? If so, who will be replaced by him? Okay, so the question says that we need to consider another batsman who has the following averages for the different batting positions, and we need to find out whether this particular batsman will be able to make it into the playing team, and if yes, then who will he replace. So let us again see, again here our objective is to find out the maximum runs that needs here. So for that, again we will have this maximization matrix, and now in this matrix we can see that we have a 6 cross 5 matrix where we have 6 number of batsmen now, and there are 5 batting positions. So we know that the first step we follow in assignment problem is to make it a square matrix. So in order to make this a square matrix, we will make a dummy column. Okay, so now this is a 6 cross 6 square matrix, and for this dummy position the run scored or the average run scored will be 0. So now as we can see here that the 6 cross 5 matrix has been converted into 6 cross 6 matrix, and now we can find the solution by Hungarian method. So let us move on to the method, and we know that after making it a square matrix we need to reduce the matrix, but before we need to understand that in this particular matrix it is a maximization matrix. Now in order to solve the problem we need to convert this maximized matrix into the minimization form. So we will convert it by selecting the maximum value in the cell. So as we can see that 60 is the maximum value in this cell, so we will subtract 60 by each element of this matrix, and our minimization matrix will be calculated. So let us calculate the minimization matrix here. So this will be 40, 60 minus 40 is 20. Similarly 60 minus 40 is 20, 60 minus 35 is 25, 60 minus 25 is 35, 60 minus 50 is 10, 60 minus 0 is 60. Similarly here 60 minus 42 is 18, 60 minus 30 is 30, 60 minus 16 is 44, 60 minus 25 is 35, 60 minus 27 is 33, 60 minus 0 is 60. Here 60 minus 50 10, 60 minus 48 12, 60 minus 40 20, 60 minus 60 0, 60 minus 50 10, 60 minus 0 is 60. Now for the next row, 60 minus 20 is 40, 60 minus 19 is 41, 16 minus 20 is again 40, 60 minus 18 is 42, 60 minus 25 is 35, 60 minus 0 is 60. Here 60 minus 58 is 2, 60 minus 60 is 0, 60 minus 59 is 1, 60 minus 55 is 5, 60 minus 53 is 7, 60 minus 0 is 60. and here we have 60 minus 42 is 18, 60 minus 52 is 8, 60 minus 38 is 22, 60 minus 50 is 10, 60 minus 49 is 11, and 60 minus 0 is 60. Now we have converted our maximization matrix into the minimization form, and the next step is to reduce this matrix, and in order to reduce this matrix we need to follow row reduction and column reduction. For row reduction we will select the minimum values in a particular row and subtract each element of this row by this minimum value. So let us start first. For row 1 the minimum value is 10, so this is 20 minus 10 is 10, here 20 minus 10 is 10, 25 minus 10 is 15, 35 minus 10 is 25, 10 minus 10 is 0, 60 minus 10 is 15. In row 2 the minimum value is 18, 18 minus 18 is 0, 30 minus 18 is 12, 44 minus 18 is 26, 35 minus 18 is 17, 33 minus 18 is 15, and 60 minus 18 is 42. Now moving on to row 3, we can see that here 1 0 is present, so the minimum value here is 0, so there will be no change in this row. So this is 10, 12, 20, 0, 10 and 60. Now moving on to next row, the minimum value here is 35, so 40 minus 35 is 5, 41 minus 35 is 6, 40 minus 35 is 5, 42 minus 35 is 7, 35 minus 35 is 0, 60 minus 35 is 25. Now moving on to next row, the minimum value here is 0, so this will remain as it is, 0, 1, 2, 0, 1, 5, 7 and 60, and this will be, the minimum value here is 8. So 18 minus 8 is 10, 8 minus 8 is 0, 22 minus 8 is 14, 10 minus 8 is 2, 11 minus 8 is 3, and 60 minus 8 is 52. So now we have done the row reduction here, and we can see that now we have at least 1 0 in each row, but we do not have at least 1 0 in each of the column. So for this we need to again perform the column reduction here. For column reduction we will select the minimum value in a column, and suppose for column 3 the minimum value is 1, and now we will subtract each element of this column by this minimum value. So let us see, for column 1 we can see that there is a 0 here, so anything minus 0 will remain as it is, so this will not change, this will be 10, 0, 10, 5, 2 and 10. Now for column 2 there are more than 1 0, so this will also be remain same, this is 10, 12, 12, 6, 0 and 0. Now for column 3 the minimum value here is 1, so 1 is subtracted from each element in this column, so this will be 14, 25, 19, 4, 0 and 13. Now for column 4 we have 0 here, so this will remain as it is, 25, 17, 0, 7, 5 and 2. Now moving on to column 5, we can see that there are zeros in this column, so this will also remain same, 0, 15, 10, 0, 7 and 3. And in the last column the minimum value here is 25, so 25 is subtracted from each element, so 50 minus 25 is 25, 42 minus 25 is 17, 60 minus 25 is 35, 25 minus 25 is 0, 60 minus 25 is 35, 52 minus 25 is 27. So as we can see that now we have zeros in each row and in each column. Our next step is to try and assign or to make an assignment in this matrix. For that particular step, what we will do is we will first assign row wise, then column wise, and if there is a single zero in a row, we will assign that row, and if there is more than one zero in the row, we will skip that row and move on to the next row. Similar method is followed for column also. So let us start here. For row 1, we can see that there is a single zero here, so we will assign this 0, and once this 0 is assigned, no more assignment can be done in this row and in this column. That means this 0 will be crossed out. Now moving on to row 2, we have a single 0 here, so again we will assign this 0, and once this 0 is assigned, no more assignment can be made in this row and in this column. Now moving on to row 3. In row 3 also we can see that we have a single 0 present, so we will assign this, and once this has been assigned, no more assignment can be done in this row and in this column. Now moving on to row 4, we have a single assignable 0 present here, so we will assign this, and once this is assigned, no more assignment can be done in this row and in this column. Now moving on to row 5, we can see that there are more than one 0, so we will skip this and move on to row 6. In row 6, we have a single 0 here, so we will assign this 0, and once this is assigned, no more assignment can be done in this row and in this column, so this 0 will get crossed out. Now let us assign column wise. Column 1 is already assigned, column 2 is already assigned, column 3 has a single assignable 0 present here, so we will assign this 0, and after assigning this, we can see that we have total 6 number of assignment here, and in a 6 cross 6 matrix, the maximum assignment can be made is 6, and this shows that our solution here is an optimal solution. Now for this optimal solution will be same for this maximization matrix. So let us see what are the allocations we have got after this. So P has been assigned to 5, okay. Q has been assigned to 1, R has been assigned to 4, S has been assigned to 1, 2, 3, 4, okay. S has been assigned to 6, row 6, that means dummy. So S has been assigned to row 6, and row 6 is column 6, and column 6 is dummy column. T has been assigned to position 3, U has been assigned to position 2. So as we can see that P, Q, R, T and U are in the playing, and the batsman S, which has been assigned to dummy column, that means that this player S will not play the game. So we can see that the new batsman U here is in the playing team, and it will replace, U will replace the batsman S, because S has been assigned to dummy column. So once this assignment has been made, we will see the total or the maximum runs that can be scored is, so for P5 is 50, similarly Q1 is 42, R4 is 60, this will be 0 because it is assigned in a dummy column. Similarly T3 is 59, and U is 52. and U is 52, and by adding up all these values we will have the value of Z maximum, that means the maximum runs that can be stored that can be scored. So we can see this will come as 263. So 263 runs can be scored by following this batting order. So I hope this clears the question, and if you like the lecture, please share the lecture. Have a nice day. Thank you.